Here we're going over an example where you have not two angles given, but two sides given. Okay, we're given side A and side C, and we're told about an angle that makes a matching pair. So first thing you should see, honestly, is I have two A's right here, which means we're going to be using law of sines. Okay, whenever you have a matching pair, we're using law of sines. So question 1 was pretty quick to answer. Question 2 is, what kind of law of sines problem are we dealing with here? Is this possibly an ambiguous case, in which case we would need to draw a second triangle and fill in those answers below? Or is this going to be a little more straightforward with only one triangle possible? Well, for that you need to examine what we're dealing with here. I have an acute angle given, and right away that makes me a little nervous, because imagine for a moment that A, okay, if the given angle, in this case it's A, it could be anything, if angle A is obtuse, that makes this pretty quick. You only have one triangle possible. It might not exist. Okay, you might have a D&E case, but at most you're going to have one triangle. You can't have two triangles if that given angle is obtuse. But we have an acute angle, which means we have to think a little bit more about this one. So now I have to make a comparison of the sides given. And if I look at that matching pair again, is the side in that matching pair long or short? If the side in the matching pair is short, then I have two triangles. If the side in the matching pair is long, I have one. And as you look at A versus C, you see that A is longer than C. So in this case, I only have one triangle. That means all this stuff down here is going to be D&E. Okay, I don't have to worry about that stuff. There's only one triangle possible. So we'll go through this thing, and I'm just going to draw, some nonsense triangle here. May or may not be accurate. And let's just put some labels on it. This might help you visualize what's going on. So I have two sides given and one angle A. All right. Now you can see right away there's that matching pair. Okay. And there's the other thing that I needed. Well, C tells me the next thing I need to find is I mislabeled these things. Sorry, no, that is not a side I'm looking for. It's the next angle I need to find is angle C right here. All right, so that's what we do. We're looking for an angle. That means I'm going to use the law of sines in its angular form with the angles on top. Sine C over C equals sine A over A. And now, since I know what C is, I'm looking for C. So I'm going to rearrange this and say sine of C equals side C times sine of A over little a. And those things I do know. Okay, I know that side C is 4.71. I know that sine of A is the sine of 49.67 degrees. That was given to me at the beginning of the problem, and I know that little a, the side, is 7.51. Okay, so that is just a little bit of calculator stuff for you to do. If you punch that in, you'll find that angle C is equal to 28.56 degrees. All right, so we go and put that right up here, 28.56. That's one of our first solutions here. And now, since we already knew A, right, that was given to us up front at the beginning of the problem, 49.67, along with side A and side C. Now take a look at this. We've got a lot to go on here. I want to find side B eventually. I'll need angle B for that. And I don't even need law of sines for angle B. I can just use the fact that all angles add up to 180 degrees. So if you just say that, let's put a little room here. Angle B equals 180 minus angle A and angle C. So what you'll get for that is 101.77 degrees. Okay, so we can put that right here. We just found something else, 101.77. And now at this point, you would go find side B. Okay, you're ready to attack the last part of that missing triangle side. And for that, you would do the exact same thing as we've done before. Put in your law of sines, give it the things you know, and B pops out.